Welcome. Pull the door shut. This file has been sitting on the table, waiting. Tonight, we investigate a world 40 light years away that keeps contradicting its own evidence. Every answer it gives us quietly opens 3 new questions. The planet is called Trappist 1b. It is the innermost of 7 rocky worlds, packed impossibly close to a red dwarf star. Scientists aimed the James Webb Space Telescope directly at it. The data returned not clarity, but a structured contradiction. A full year here lasts only 36 hours. That is not just a curiosity. It reveals the brutal gravitational grip of this system. 6 sibling planets tug on Trappist 1b constantly from every orbital angle. That relentless mechanical pressure is the first suspect in this investigation. This gravitational squeezing generates internal heat, not from the star, but from friction deep inside the planet. Scientists call this tidal heating, and it is a known process. But the scale operating here may exceed anything we have previously measured. Tidal heating on Trappist 1b is not a background process. It may be the dominant geological force on this world. Jupiter's moon Io is the most volcanically active body in our solar system. It exists because of tidal heating from Jupiter's immense gravity. Trappist 1b sits in a far more gravitationally complex system, with more pulling forces. If Io is the baseline, this planet may represent a category of volcanic violence we have no existing name for. Here is the detail that halts every model cold. The surface of Trappist 1b may be less than 1,000 years old. For a planet billions of years in existence, fresh crust at that age means only one thing. Something planetary in scale is continuously destroying and rebuilding the ground itself, and that process has not stopped. Every rocky surface in our solar system carries damage. Radiation, micrometeorite impacts, and chemical weathering leave a deep, readable record over millions of years. Trappist 1b shows none of that expected accumulation. The surface is forensically clean, as though the planet has been methodically erasing its own geological history on a rolling schedule. The star, Trappist 1, is not a quiet background variable. It is an active, volatile red dwarf covered in massive star spots and prone to sudden, powerful flares. These flares produce what researchers call ghost signals, false readings that can perfectly mimic or completely mask an atmosphere. The star is, in effect, contaminating its own crime scene. If you could stand on the Terminator line, the star would sit frozen on the horizon. It would not rise or set. It would simply exist there, a large salmon-pink disk, motionless against a black sky. No wind patterns we know would apply. That fixed sky is the permanent, unblinking condition of life in this world. Tidal locking means one face of this planet is in permanent, scorching daylight. The opposite hemisphere sits in permanent, freezing darkness. Between them, the Terminator line is a band of eternal twilight, neither fully lit nor fully dark. That boundary is not just a geographic feature. It is the most thermally complex zone on any known rocky world. From that Terminator line, 6 sibling planets would hang visible in the sky. Several would appear larger than our full moon looks from Earth. Their gravitational presence is not decorative. Each one is actively pulling on Trappist 1b at all times. This system does not have isolated planets. It has 7 bodies and a constant, measurable mechanical conversation. The James Webb Space Telescope stared at this planet for nearly 48 hours. That investment of time produced exactly 2 data points, 2 measurements from the most advanced observatory humanity has ever built for a single rocky world. That ratio alone tells you how resistant this planet is to being understood. The first measurement came back clean and definitive. The dayside temperature read approximately 230 degrees Celsius, hot, but predictable for a bare, airless rock at this orbital distance. Scientists briefly thought the case was closed. That conclusion lasted until the second wavelength of infrared light told a completely different story. The second measurement did not match the bare rock model. The temperature reading was lower than an airless surface should produce at that stellar distance. A lower temperature at that proximity to the star means only one thing. Something is redistributing heat. That something, by every physical model we have, would have to be an atmosphere. 2 wavelengths of light. 2 contradictory temperature readings. Same planet, same telescope, same observation window. This is what investigators call an internal inconsistency. And in planetary science, internal inconsistencies do not resolve themselves quietly. They are the signature of a system hiding a variable we have not yet identified. Scientists are now building what is called a phase curve for this planet. As Trappist 1b orbits, its brightness changes in a measurable pattern. Tracking that pattern reveals how heat moves, or fails to move, from the day side to the night side. A bare rock holds heat locally. An atmosphere spreads it. The phase curve will force one of those 2 models to break. Here is where the smog theory enters the investigation. If Trappist 1b has an atmosphere, it may not be clean or thin. It could be saturated with hydrocarbon haze, thick, photochemically generated smog sitting high in the upper atmosphere. This kind of haze layer does something physically unusual. It warms the upper atmosphere while cooling the lower, a complete inversion of standard atmospheric behavior. This atmospheric inversion has a name, a thermal inversion, and it is rare even in our own solar system. Saturn's moon Titan carries a version of it, wrapped in its own dense hydrocarbon haze. But Titan is extraordinarily cold. Trappist 1b would be running this same atmospheric architecture at searing heat. That combination has no direct analog anywhere we have studied. The smog layer creates another forensic problem. A thick carbon dioxide atmosphere should be detectable. CO2 absorbs specific infrared wavelengths in a predictable, well-documented pattern. But a high-altitude haze layer can emit its own infrared radiation, canceling out that absorption signal precisely. The atmosphere, if it exists, may be actively engineering its own invisibility. A magnetic field adds another unresolved layer to this case. Some researchers propose that if Trappist 1b possesses a magnetic field, it may be interacting directly with the star's own magnetic field. That interaction could generate supplemental internal heat, compounding the tidal heating already suspected. A planet warming itself through 2 simultaneous invisible mechanisms is not a simple object to model. There is also a purely speculative but structurally valid question. Could this planet have rings? The same tidal forces driving its volcanism could grind up captured debris or fragment small moons over billions of years. That material could form a ring system we have not yet resolved in our imaging. No evidence confirms this, but no evidence rules it out either. NASA recognized that this planet could not be solved with casual observation. A dedicated program called Rocky Worlds was created specifically for cases like this one. It will commit 500 hours of James Webb Space Telescope time to studying small, rocky worlds in tight stellar orbits. That level of institutional investment signals that the scientific community considers this mystery genuinely unsolved and genuinely important. Trappist 1b has spent billions of years orbiting practically at the skin of a volatile, flaring star. The question investigators keep returning to is not simply whether an atmosphere exists now. The deeper question is how any atmosphere could have survived that long under that sustained bombardment. Atmospheric retention at this proximity to an active red dwarf is a physics problem with no comfortable answer yet. The planet's interior should be cold by now. Worlds of this size and age typically exhaust their internal heat budget over geological time. Their cores solidify. Their volcanic activity quiets. Trappist 1b shows no sign of that cooling trajectory. Something deep inside is still generating massive thermal output, and the source of that sustained internal energy remains an open variable in every current model. If the volcanic model is correct, this planet may be offering us something extraordinary. It may be a living snapshot of Earth during its Hadean Eon, a period over 4 billion years ago when our own planet was covered in magma oceans and toxic atmospheric chemistry. We cannot observe ancient Earth directly, but Trappist 1b may be running that same primordial program in real time, 40 light years away. The Hadean Earth eventually stabilized. Volcanic outgassing built an early atmosphere. Crustal cooling allowed liquid water to pool. That sequence took hundreds of millions of years to complete. Whether Trappist 1b is at the beginning of a similar stabilization sequence, or permanently locked in geological chaos, is a question that current data cannot yet distinguish between. Both scenarios fit the evidence equally well. This planet is also a measuring instrument for its siblings. Trappist 1b sits too close to its star for liquid water. It is firmly outside what scientists call the habitable zone. But the atmospheric behavior it demonstrates directly informs what is possible for Trappist 1e, F, and G, which orbit in cooler, more temperate positions. Understanding what this world lost tells us what those worlds might still have. The classification problem for this planet is genuinely unusual in modern planetary science. Investigators have 3 distinct, internally consistent models sitting on the table simultaneously. A bare, irradiated rock. A volcanic hellscape resurfacing itself continuously. A hazy smog world with an inverted thermal profile. Each model is supported by a real subset of the available data. None of them has yet broken the others. The first James Webb observation was built on a single infrared wavelength. Scientists drew a firm conclusion from that single channel of information. That conclusion was then directly contradicted by a second wavelength measurement. This sequence is now studied as a methodological caution, a vivid example of how one data channel, even from an instrument of this precision, can produce a confidently wrong answer. The terminator line of this planet deserves its own place in this investigation. That permanent twilight band would experience conditions found nowhere else in this system. Intermediate temperatures, complex chemical gradients between the hot day side and the frozen night side. If any process on this planet is creating localized chemical complexity, the terminator line is the most probable location. It is the only geographically stable transition zone in the entire world. Orbital resonance connects all 7 planets of this system in a precise gravitational rhythm. Trappist 1b is the innermost anchor of that chain, the planet absorbing the highest cumulative gravitational stress from every sibling simultaneously. Its orbital period of 36 hours is not an accident of formation. It is a mathematically locked position, held in place by the combined gravitational arithmetic of 6 other worlds pulling in coordinated sequence. The Rocky Worlds program is not studying Trappist 1b in isolation. It is building a comparative framework across multiple small, rocky planets in similar stellar environments. Trappist 1b is the anchor case, the world that sets the baseline for what extreme proximity to an active red dwarf actually does to a planet over geological time. Every other rocky world in the program will be measured against what this one reveals. There is a specific forensic term for what scientists are doing with this planet's brightness data: secondary eclipse mapping. When Trappist 1b passes behind its star, the total system brightness drops by a measurable amount. Comparing that drop across multiple wavelengths builds a thermal map of the dayside surface. That map is currently the sharpest tool available for forcing the 3 competing models toward a single, falsifiable answer. The ghost signals produced by Trappist-1 stellar activity are not random interference. They follow patterns tied to the star's rotation period and flare cycle. Researchers are now building stellar contamination models, mathematical filters designed to strip the star's own noise out of the planetary signal. Until those filters are validated, every atmospheric measurement carries an embedded uncertainty that cannot be cleanly quantified. The star remains an active variable inside every equation. Consider what the sky above the night side of this planet would look like. Permanent darkness, but not emptiness. 6 planetary bodies moving in slow, visible arcs overhead, some subtending angles larger than our moon. The star is permanently absent from that hemisphere. No solar radiation reaches the surface directly. That night side is one of the coldest, most radiation-sheltered surfaces in this entire planetary system. Every investigative thread in this case connects back to a single unresolved node: the atmosphere question. The young surface connects to volcanism, which connects to outgassing, which connects to atmospheric generation. The thermal inversion connects to hydrocarbon haze, which connects to photochemical reactions requiring ultraviolet input from the star. The magnetic field question connects to internal heat, which connects back to volcanism. This is not a collection of separate mysteries. It is one mystery with many entry points. Here is what the current best evidence actually supports. The phase curve data, combined with the secondary eclipse measurements, shows that heat is not staying fixed on the dayside the way a bare rock would hold it. Something is moving thermal energy laterally across the surface or through an overlying medium. That behavior is physically consistent with atmospheric circulation, a thin to moderate atmosphere actively redistributing heat from the dayside toward the terminator region. The smog hypothesis now carries the strongest explanatory weight among active researchers. A hydrocarbon haze layer sitting above a carbon dioxide-rich lower atmosphere would simultaneously explain the thermal inversion, the masked CO2 absorption signal, and the anomalous temperature readings across both measured wavelengths. This model does not require any exotic physics. It requires only that Trappist 1b is doing at extreme heat what Titan does at extreme cold, and that comparison is now taken seriously in peer-reviewed literature. The volcanic resurfacing model and the smog atmosphere model are not mutually exclusive. Intense volcanism would continuously pump sulfur compounds and carbon dioxide into the lower atmosphere. Ultraviolet radiation from the star would process those gases into complex hydrocarbon chains in the upper atmosphere. The young surface, the haze layer, and the thermal inversion may all be outputs of a single underlying engine, a planet generating its own atmospheric chemistry through geological violence, in a continuous, self-sustaining cycle. If this investigation kept you locked in, subscribe, because every case file we open goes deeper than the last. Trappist 1b is proof that one small world can dismantle everything we assumed we understood. The Sleep Lab stays open, and your subscription keeps you inside it.